Reverse chain rule. Now, I should say it's reverse chain rules because if you remember, when you were learning differentiation, right? Whenever you have a function of a function, which is the other name for chain rule, right? Whenever you have a function of a function, there are different kinds of functions, right? There's trig, and then there's exponentials and logs, and we're just going to cover polynomials, okay? So just like there are many different sort of versions of chain rule, there are also many different versions of reverse chain rule. So we'll look at them in turn. I don't know how far we'll get by the end of term, we'll just see, okay? So where do we use this? When you have something like this, let's call this f, okay? If I were to say, well, okay, what is the primitive of f? Or what's f prime is another way of saying it. So capital F, okay? What's the primitive function of it? What's the family, okay? Now, so far we've resorted to just expanding it out, okay? And the expansion is? Good, okay? And then we just take it term by term, like we normally do, okay? So practice it with me, right? We should be pretty good at this by now. We've been spending a couple of lessons at it. Yeah, good. Power goes up. Excellent. Plus, good. Good. And we have to state what c is, right? So it's a constant or fine, okay? But this is okay since the power is 2, but if the power is higher, it starts to get a bit of pain, right? So, we did sort of, when we had something like this, if I made the power, sorry, let's leave that as a 1. If we made the power 100, okay? Just like with differentiation, let's work out what f dash is, okay? So that we can practice chain rule. We want to be able to do this in a way which avoids the expansion. Expansion is super inefficient as this power goes up, okay? Because this expansion is going to have 101 terms in it, okay? So it's going to go really, really long, and then you've got to anti-differentiate every single one. So that's a pain. So let's just rehearse the way regular chain rule works. What's the first step that I do?
Inside, differentiate the inside.
Yeah, okay, differentiate the inside, which is 1, okay? And then I do the outside, which works just like a normal one, right? So the 100 comes out the front, and then the power goes down. Yes? Okay, and the 1 out the front turns out to be inconsequential. So no problems, okay? Well, let's just consider, if we wanted to work out what the primitive was instead of the derivative, well, so far the way we worked out anti-differentiation with these guys is we just turned the previous process, differentiation, we just did it in reverse, yeah? Did it backwards. So let's try and do it here. This is what I've got, right? In this case, I brought the power out and reduced it by 1, okay? And I multiplied by the derivative of the inside. Is that okay? So let's try it this way in reverse. What's the first thing that I should do?
Add the power.
Okay, so with one thing to note, multiplication and division, right? I can do them in any order I like. Because if I multiply and then I divide, or divide and then I multiply, you'll get the same result. Okay? So whether I do the inside or the outside won't matter that much. So let's do the outside first, because that's what you guys are saying. Power goes up by 1. So let's try this. X plus 1, 101. Come in. Hi, Richard.
Sorry, I was at the accounts office. And
That's
then I
okay.
had to see Mr. Gorga go back to the accounts office.
Take a seat. The power's gone up. Now, here I multiplied, so now instead I divide. Okay. Now, I also probably ought to divide by the derivative of the inside, right? Because in this case, that's what I did. Well, I multiplied, right, by the derivative of the inside. So now I'm going to divide by the derivative of the inside, which also doesn't have an effect. Okay, sorry, I really shouldn't. There we go. Okay, does that make sense? So, how would I know whether I've got it right or not?
You can differentiate.
Yeah, we've been noticing this, right? So because anti-differentiation is just the reverse process, sorry, a bit naughty, I should be able to differentiate and get back my original function. Yes? So let's just give it a go. Okay? I'm going to take the derivative of what I've ended up with over there. Okay? Just x plus 1 to the 101, that plus a constant. Okay, does it work? Power comes out the front. Power reduces by 1. This is already there. Constant disappears. 101, 101. That looks good. No problems. That's pretty good. Does that make sense? Happy so far? Okay, let's change it a little bit. Let's take an example like, what if it was 2x plus 1? Okay. What do you think? What should we do first? We could do it in the same order that we did it before. Right? Power up! Okay. In so many years of teaching privilege, no one has ever... Anyway, okay. Power goes up, right? Divide by the new power, and I divide by something else. What do I have to divide by? The 2, which is the derivative inside, okay? So multiply by 2. So I'm dividing by 202. Does it work?
Yes. No what?
Does it work?
Yes, it does.
It does work, doesn't it? The 101 comes out the front, and then the 2 will also come out the front, which exactly cancels out 202. Because we went through all the steps and we just reversed them. Okay?